is also equal to 10 kilowatt, okay, output. Right. Then the next one, I think you all will know the reason now. Knowing that the allowable shear, right, is 50 megapascal, determine the smallest possible diameter of the shaft. Okay, so now you all of you know that why they give what allowable. Right now you know why. Okay, because by integrating Mohs circle together with structure analysis of the shaft under torsion, under bending, okay, we are going to use Mohs circle, and the criteria is going to be allowable shear, because the shear stress has a lower magnitude than the normal stress in yield. Period. Done. Okay. Now, what if next time what if you are in industry and then someone say, Sunshine, material use has a use strength. Then you say, no, use strength not good for me. Then they ask you, what do you need? I need shear stress. And then the principal engineers give you the bird. I don't have that property. So let's say if now you're given, okay, allowable to be 175 megapascal. How are you going to do your calculation? Anyone? How? So like what I taught you before. So if this is given, okay, you have to declare this. Okay, so you're going to write this based on Tresca, okay, yield criteria. Okay, based on Tresca yield criteria for ductile material. Okay. All right, for ductile material, right? You can say that the stress, the shear allowable is equal to normal stress allowable divided by 2. So this is equal to 85 megapascal. Okay. Okay. So immediately you can link based on that. Okay. You can based on what Tresca. Okay. You have to describe this. And if your principal engineer does not know Tresca, give him the book or ask him to watch this video. Okay, which is me. Right. Okay. So we are going to analyze two things first. Okay. So if you look at our equation, so our equation is shear allowable. So let's see where's our equation. Let me bring our equation over. Okay, so this is our equation. Okay, so that's our equation. So in order, so what we are tasked to find is we are tasked to determine the smallest possible what diameter. Okay, so these two values, right, we don't know. Okay, so the only values we know is this, and for now we don't know moment, we don't know mz, we don't know our what tx, we don't know them yet. So that is what, so we have to find the moment and torque at specific locations. Okay, so now we are going to we're going to look at, so the first thing we do, okay, is we're going to, let me get another image. Okay, I'll take the big one again so you can see better. Okay, once again, all of us will say this. Okay, equation is really easy. Okay, again I mentioned this, the equation is very what easy. The difficult part is always the what analysis. Okay, I repeat again, the difficult part is always the what analysis. Okay, so we are going into analysis first. Okay, now, so I'm the first thing I'm going to write out tricks that I've learned. Okay, that we can't read from textbook. Okay, but tricks I've learned that always work. Okay, so number one, determine the rotation of the input shaft or input gear. Okay, right? The first thing we're going to do. So if we look at the direction now, we realize, hey, this is the what? This is the direction, right? So if we use the right hand rule, if we use your right hand rule, okay, and I'm going to call this direction is my X, okay, this direction is my Y, and this is my Z, okay. So this is the direction of my moment in Z. Okay, wait, let me, yeah, you can let me write in a different color. Okay, this is I don't know whether can you see this color better, but okay, so this over here is your moment in Z, X, sorry. So the moment in X we can see is negative, but don't worry about the negative, right? So the next thing I want you all to watch is number 2, focus on the contact point of the gears. Okay, so we know that the input between E and the motor, right? So this is where the contact is. No good color, Eugene. Come on, wake up. So this is where okay, this is where the contact is. Okay, so this is where the contact is. Right, then you have another contact is over here, and then we have another contact is over here. Okay, so find where the contact points are, right? Okay. Then the next one, determine the force of the, it means the applied force at the contact points or point for the input gear. Okay, so for this case, right, the rotation is what you see down there, right? So question for you, is the forces going up or the forces going down? Anyone? Up or down? The applied force, the input force.
They're coming down on the y-axis.
Well done. Okay, coming down. Okay, so you got that. You got that over here. So it's coming down. Okay, so from here, right, we know that there's a force coming down. Okay, and this is what I call P. What do I call? I call F. Okay, at point E. I don't know like this. So this is where we call F at point E. So the next thing we have to do is we have to determine, okay, the next thing we have to do, determine the force direction at point at gear C and D. Okay, so we're going to determine at C and at point D what is the direction of the force. Okay, now what I'm going to do now is I'm going to sketch. Okay, I'm going to sketch a view. Okay, I'm going to sketch the view. Now, ladies and gentlemen, if this part is wrong, okay, this like first few step is wrong, the whole answer is down the toilet bowl together with the kitchen sink. You know, everything goes down. Okay, okay, and there's only one type of engineers can analyze this. Who is it? Anyone? Talk to me, man. Who?
Mechanical engineers.
Thank you. Okay, you give a civil engineer or any other engineers to do it. We know what they say. Make it as big as possible, as long as it's smaller than the what? The size of the gear. Okay, I better stop this, okay? Because some of your friends can be material science, okay? I'm in the big duda, okay? Okay. Okay, so we are now going to view from the Y and Z, okay? Or you want your friends that is in civil engineer to know, ask them to watch the video, okay? But you have to protect your speciality, okay? That's why there's no more Chinese Kung Fu now, okay? Oh God. My wife said that my jokes are very lame, and I think she's right. Vidu-san, while I'm drawing, let me ask you, why Chinese Kung Fu is dying? Anyone? Or cease to exist anymore? Do you know why?
Is that specific towards me?
Yeah.
Because everyone knows about Kung Fu now and everyone does it. So like, is that
No.
why?
They now not anyone know about the skills of a Kung Fu now. Why?
Kung Fu Panda?
you and your Kung Fu.
I actually don't know.
Okay, I'll tell you why. Okay, but I have to focus first. So this is 1/6. So this is the anyone know the reason why the art of Kung Fu is missing now? Anyone? Please help me. So this circle I've drawn, you can answer anytime regarding the Kung Fu. Okay. This is gear E. Okay.
Is it because people fight with guns now and not hand-to-hand combat?
That is what I call a creative engineer. Okay. No, not that. Okay. So this is our motor. Our motor gear. So I'm looking at the front view. Okay. Right. So we just mentioned that this is coming this way. Right. So the transmission of the force come on, anyone with the Kung Fu answer? Come on. Because I'm drawing, it's boring for you guys. Entertain me. Anyone? Yes.
Is it because they don't teach it to a lot of people?
Exactly. You got it right. And from your accent, I don't mean to be yeah, you are Chinese. Am I right?
No, I'm Filipino.
Same thing, same thing. Okay, and you're absolutely right. Because the master will teach everything except the most powerful weapon or skill. Okay, he will keep it himself so that the student will not kill the master, right? And then when the student become the master, the same thing happen. So they keep for themselves, you know. They keep from themselves. Okay, now the one I've just drawn, this is the shaft. Okay. So this is the shaft to determine diameter. That's why the skills of Kung Fu gone missing nowadays, okay? You get all the BS coming out. Okay, right? So that is the shaft that